Welcome back to the channel. Episode 2 of the Kafka series kicking off right now. In the first episode, I really covered everything about what the sample's supposed to do, how to use it, how it uses Confluent Cloud, how it uses MongoDB Atlas, how to navigate all those different UIs, get it set up. Hopefully you've pulled down the sample, you've kind of messed with it a little bit, and now you're like, okay, how does all this code work together? So let's jump right in and find out. I'm going to start with the API producer because I feel like that's where we want to start. We're putting messages into Kafka. So I'm going to start with the program CS. I want to kind of show you how you configure a writer, what a producer is, and then we'll go into the back end, which is how we configure consumers, sagas, so forth like that. So you can see in the code, I'm going to use MassTransit. Boom. I've got some MongoDB configuration. I'm going to skip over that for now because these are a few things. As I pointed out, no bus is used here. We're just saying using in memory because we have to have one, but no RabbitMQ, no Azure Service Bus, nothing. We're going to go straight into the writer. Now in here, I add some Kafka components. When you're using Confluent Cloud, there's a few things you need. First, I configure the options so I can pull all the connection string stuff out of the app settings.json. I also configure the schema registry options, which again, pulls out of app settings. And then I configure the schema registry client. So with Confluent's client, anytime you create a producer, you need to register the schema registry client. And the reason for that is Confluent Cloud is going to keep track of all the different message contracts and ensure that any evolution of that contract is backwards compatible. So super cool, super useful. This is all the boilerplate setup you need for like the registry URL, the credentials. It all uses SASL authentication, username and password. This is how to set it up. Super easy, awesome. All done for you. Now, the other thing with the producer and with this API is, this is an API that's used by a warehouse that's going to be reporting data back up to that Confluent Cloud. So I wanted to be able to configure in the app settings, the correct app settings would help, the warehouse event. So in this case, events warehouse 47. That's the topic that I'm going to be using for writing these events. And actually, it's not, but I don't want to show you my app settings. I actually get an int of warehouse.location, and that's the location for this warehouse. In my settings, it's 47. And what I'm going to do is I'm going to format up that topic name of events.warehouse.47 because I want to write to a unique topic for each warehouse. Now I'm going to create two producers in my configuration for this writer. So I'm going to say r.add_producer, and when you produce messages to topics in Confluent Cloud, you get two things. You have a key and then a value. The value is what we would traditionally in MassTransit refer to as the message type. The key can be anything. It can be an actual data type, and you'll specify a serializer for it if it isn't a built-in type. I'm just using a string because I don't want to do anything too crazy here, but you could actually put anything you want in here. Kafka, all these are is byte arrays. Kafka just deals with byte arrays and a log. It's a big, massive log file that's appended front to back. But by telling it the schema and telling it the types, it's able to pull that data out. And as you saw in the first episode, we could go in and actually look at that message data in the UI because those schemas have been uploaded through that schema registry. So fully supported by MT, all of that sharing is great. I'm using Avro in this sample. You can use JSON. I just don't because Avro is super tight. And it's super awesome for Kafka because everything supports it. It knows what Avro is, makes it super easy. So when we add a producer with a writer, we're going to give it this string and warehouse event. Warehouse event is my type. Again, this is that Avro generated code that's been built with AvroGen, and it's a specific type. And this is what is considered a union type in Avro. I'll cover that in a second. I'm going to start first with the shipment manifest received because this is our other producer, and this produces to the global events.erp. It's in this project. Ideally, this would be a separate API used by your ERP platform, but I didn't want to have too many projects in this thing. So I just plugged this API in here, and this producer is configured. It's also configured with Avro, same schema registry client, shipment manifest receipt. So let's look at what this contract is. Now, this is a generated type. If I mouse over it, I can see it's generated code. Let's go look at the actual ERP contracts. So this is an Avro record schema. And in here, I've defined a product type, which has a SKU and a serial number. And then I've defined a shipment manifest received that's going to get dropped into the sample contracts namespace. And it's generated code. It has all of those values that I need. So it's going to generate out something. I have an array of items, which I can then just process with that produced message. So we'll look at that when we go into some of the controller code. So let's look at some of these controllers. In this case, let's look at that manifest controller. So we've configured Kafka at this point. Oh, I said using Kafka, I configure the host. I'm just passing context because I want to pull it out of the container. This is going to go out and get that IOptions of Kafka options. It's going to configure the host with the servers that are configured in the app settings JSON. It's going to get configure the security permissions. These are specific to Confluent Cloud. This is what is required by Confluent Cloud. If you're using Kafka locally or on-prem, your options may vary, but this is what's required to get it working with Confluent Cloud. Super easy to set up. Just cut and paste out of this sample if you're going to use it, or just use the sample to start. That's all that's in the API thing. So let's look at what a controller using one of those producers looks like. We're going to start with the manifest controller, because this is the one that gets us that purchase order with the detail of products that comes in and uses that shipment manifest type. You can see I'm just going to new it up. I'm going to set up all the properties on it. I'm going to create the items list. I'm going to throw all of the detail that was uploaded. This is just a model type that I can upload with the appropriate items in it so that when I paste that JSON in from Postman, and I'm taking in that topic producer from the services for string shipment manifest received. And I'm just doing producer.produce. I'm setting that string key equal to the purchase order number. And the way Kafka is going to work is it's going to automatically assign a partition based on that key value. So if that string is the same, all of the messages with that key are going to end up on the same partition in the topic. If you keep that's something to keep in mind. Assigning keys is important because if you care about in-order message processing, which MT fully supports with Kafka, you have to make sure that your messages that you want in order have the same key. But if you give them different keys, MT will actually scale out across multiple partitions, multiple keys, so that you will still get messages in order as long as the key is the same. If the key is null or empty, you'll get one message at a time. Just how it works. You can't scale out without something to scale on. MT will scale out per partition. So if you're specifying a partition ID, it will. But it will also scale out based on that key so that you get your messages in order one at a time. You can actually override that too, but that's a side point. Most people want this in order, but it scales out and it will actually increase the number of Confluent consumers we are running to consume multiple partitions concurrently. So a lot of cool features were just added in the latest release that make this possible and add a lot of this scaling capability. Super slick stuff. So that's our manifest controller. We do a produce, and then when we hit that, it landed on the topic, and then the processing happened. All the other controllers are basically the same. We have the receiving controller, which produces the warehouse event. But note about this warehouse event. Let's look at this contracts for that. Inside the warehouse event, I have 3 different types that it can be. And this is called an Avro union type. And this requires some special handling in MT because the message type is warehouse event, but inside that message type, I actually have 3 other message types: product received, product picked, and container shipped. Now, I've seen companies use this because they want to transfer a specific piece of data and they want to have it wrapped in a common envelope, but they want to have a union type for like the 3 or 4 different types of messages that would fit in that envelope. I think Cloud Events follows a very similar thing where you have a fixed envelope and then there's like a type in there that lets it switch out. And I'm going to show you how I supported Avro union types in the sample because MT doesn't have it built into the package because it's all tied to Avro, and I would have to have a separate Avro package for that. Haven't made that leap yet. So I'm going to show you how this works. So within the controller producing any of these warehouse events, you can see I create the warehouse event, I set the common data, and then for the actual event, I set it to one of the 3 types. In this case, I'm doing product received. I'm setting that purchase order number, SKU, and serial number. The other controllers that pick In this case right here, same thing, but in this case, it creates the product pick event type for the event. And in the case of the ship controller, the event is container shipped, and it passes that in. All of the outer warehouse event types are the same. So we're actually putting multiple message types, technically one warehouse event, into the topic, but using an Avro union type to say, I want these 3 different messages because they're closely related in business context on this topic. Hopefully that's understandable. That's all I'm going to kind of cover for producers on that. Once those are done, the messages end up on the topic, and that's all the API service does. The API service itself in the receive controller has one additional thing that it checks. So remember when I said in the first episode, when we receive a product, we want to check that MongoDB table or collection. Sorry, it's a collection in MongoDB. We want to check that collection to see if that product is expected at that location 47. And so the way we do that is I actually have a validation service that validates the product receipt as part of that API controller. And in here, I actually just go out to that MongoDB collection. I start a session, I build a filter to say, hey, product location where SKU is this, serial number is this. Do I actually have one? And if I do, is the location what I expect? Because I'm at location 47. If it's what I expect, is valid as true, solid result. If not, I return an error and say the product was expected at a different location. So if I were to go into that postman and do a receiving and say, hey, I'm going to collect this, but I'm at location 21, I would actually get a 409 conflict and say, I expected the product at location 47. Whereas if I come back and put 47, I can see that, oh, everything was good. I accepted it. That front-end validation happened before I actually was putting the message onto the topic. So that is the producing side of the sample and all of the code that's within the sample warehouse API. The next thing I'm going to touch on briefly is the receiving side. So all of the receiving happens within the background program. And the background program is configured very similarly, except in this case, I'm adding my consumers. I have my shipment manifest received consumer. And I have my saga, my container state machine, which is using a state machine saga. The shipment manifest received consumer is fairly simple. It uses the MongoDB collection. It starts a session. It takes a look at all those products, and then it does a replace one async with the is upsert true. So this is that upsert into MongoDB to say, hey, this product with this SKU and this serial number is expected at this location. And it does that through all of the products in that line. It then commits the transaction using MongoDB transactions, which have been there since like Mongo 4, and stores all of those items into that collection as a single operation. Pretty cool. The container state machine is the state machine that's handling those 2 different events, both product picked and container shipped. And here's where it gets kind of cool. So as I said, according to MassTransit, I'm just receiving a warehouse event. And let's dig into that. I don't want to dig into the state machine totally on yet because I don't want to make this too long. But when I'm going to configure the topic endpoints, as I say using Kafka and I set the host, the first thing I'm going to set up is the shipment manifest received. This is that single consumer. And I'm going to listen to that events ERP topic with the ERP.backend consumer group. I'm going to tell Confluent that if you don't have a previous offset saved for this consumer, start at the oldest item. I want to go way back in time to the beginning. Otherwise, pick up where I left off. I'm going to set up a value deserializer because we're using Avro. We have to tell it how to deserialize Avro with that shipment manifest received, get the schema client. And what's weird about Confluent is deserializers are actually not async, but serializers are async, but yet it's a single interface. So it's kind of weird. I don't even argue about it. I'm just passing this Avro deserializer in. I'm going to run it as a synchronous call through, even though it's async. Don't talk to me about the API. It's just kind of weird that way. I'm setting that my concurrent message limit is 10. This means I will receive up to 10 messages per partition if this events ERP topic is partitioned. I do a sample retry config. I'm not going to do that. And I just call configure consumer for that shipment manifest received consumer. Done. My consumer is configured on the topic endpoint, and that's ready to go. The state machine is a little cooler because it's using what's called a wildcard topic. So you can see the topic name here is events.warehouse.some number star. This is saying that any topic that matches that pattern, I want to consume with this topic endpoint. So with a single topic endpoint declaration, I'm actually able to consume from a whole bunch of topics. If there's 100 topics, I'll consume from 100 topics, and it will actually assign partitions from those topics to this topic endpoint based upon availability and what has messages in it. Same serialization, same that. Concurrent message limit, I can consume up to 10 messages per partition. Again, if those keys are different, I will consume up to 10. If the keys are the same and have the same string value, I will consume 1, because we can only scale out if we've specified that we want to do, if we have keys that are distinct. If it's the same key, I'm going to process those in order to consumers and wait for those consumers, sagas, whatever, to complete. I can also configure a concurrent consumer limit to say, I want to consume from up to 2 consumers at a time. These are Confluent consumers. And I want to say, okay, I want to consume from 2 topic partitions or 2 topics at the same time. I could scale this up to 10, and it could really, create some super high throughput. The other one is the concurrent delivery limit. We're defaulting this to 1. If you increase this to 1, message order is not guaranteed, because you're basically saying, hey, even if they have the same key, I just want all the messages you give me, because I'm just, maybe I'm just doing upserts, order doesn't matter, doesn't care. It's whatever we want to do. Yeah. Then I'm saying I want to support Avro union types, and I do that through some middleware that I configure on the consume pipeline of MassTransit. I configure the saga. Great, container states there. We've seen that in other things. I actually handle this product receive event because the saga doesn't. And if I don't, I get a weird error in the log. I've got to look into that because we should be discarding skipped messages, but it doesn't. So maybe I got to go look at that. It's only really an issue because I'm not actually consuming warehouse event anywhere in this code. I'm consuming the product picked and product shipped events in the state machine. So the fact that I'm only consuming these 2 events, kind of interesting. So, and I'm going to go into that a little bit and then kind of cover up in future episodes some more details. So I've created a middleware filter for the Avro union message type, which lets me say, I want to handle messages off that event property in that warehouse event. And the way this works is under the covers. And if you look in the sample and jump ahead, that's great. But if not, I'll cover it in the next episode. But this lets the MassTransit consume pipeline look at that warehouse event. And if the saga says, hey, is it a product picked? It will look at that event property and say, hey, are you a product picked event? And if you are, it will dispatch that message as a product picked event. So the MassTransit consume pipeline is pretty sophisticated. It does a whole bunch of type-based routing. And this filter is actually extending that type-based routing to support dispatching off of properties in messages. And it'll work for any, you can use something similar for any type of message that has like an object property on it, or that can be multiple types. It's just a way to take advantage of those Avro union types with MassTransit without having to say, consume warehouse event, and then saying if warehouse event is in your code and doing all that branching in your code. I'm doing it at the message type level using the consume pipeline middleware features. So I'll dig into that in one of the next episodes and show you deep how that works. I wanted to get through the whole topic endpoint in this episode. So here I configure the saga. When I start it up, everything starts up, everything is running, and that's where those process. So that's how you configure producers and topic endpoints in Kafka. There's a lot of options you can do to dial up the speed, dial up the throughput, set your serializers. A lot of flexibility, a lot of stuff I'm not going to cover because it's all IntelliSensible and it's extensions of what's in the Confluent client. But we've put together a lot of sensible defaults here. And like I said, giving this approach, you can get a ton of throughput based on partition and topic counts of your application. So thanks for joining. Next episode, we'll go deeper into a few other things. But hopefully at this point, you can get through the sample, you can get it running, and you can start tweaking it and adding your own code to do your own thing. So thanks for joining. Next episode, see you then.